thing about transport layer. So let me mirror and then we'll start. Yeah. So, when we are going to be talking about your transport layer, so again, the third layer was your network layer and the fourth layer is your transport layer in your OSI reference model. Okay. So your transport layer. So we can say this is going to be the fourth layer in OSI reference model. All right. Apart from that, when we're going to be talking about the transport layer, so this one is going to be responsible for your process to process delivery of your entire message. So whatever is going to be there in your message, this one is going to be held responsible for the end-to-end delivery for the same. And when we are going to be talking about the process, so a process is basically an application program that is going to be running on the host. Then when we are going to be talking about the basic functions of the transport layer, so what it actually does, so it is going to be accepting the layer which is going to be above to it, and what it will do, it is going to be breaking it down into smaller pieces. And then what it will do, it is going to be passing the data units to the network layer, and at the same time it is also going to be ensuring that all the pieces are arriving correctly in the other end, and that is actually important. Otherwise, let us say you are sending a normal text message, what if it is getting sent in different parts and those parts are not even synchronized? So obviously it is not going to form a meaningful message. So that is the reason a sequence is actually going to be important. And when we are going to be doing all these things, the first thing which we will have to ensure that we are performing all those activities efficiently, and we are going to do it in a way that is going to be separating out the upper layer from the whatever changes we are going to be having at your hardware level. All right. Also, when we are going to be talking about the transport layer, so it is also going to be ensuring that what kind of services we will have to provide to our session layer, and ultimately whatever the users are going to be there on that particular network, and the most popular type of transport connection is actually going to be the one which is not going to have any of the errors. So that particular one is always desirable, where we have error free point to point channel which is going to be delivering the messages or the bytes in the order in which they were actually sent. All right. Then when we have to talk about the transport layer, so we can say it is a true end-to-end layer. So we can say true end-to-end layer. All right. So in this particular one, what is actually going to happen whenever you are going to be sending a message from your source to destination, in such a case, we are going to be ensuring that it is passing it in the proper form. So in this one, what is actually going to happen, we are going to be having a program which is going to be there on the source machine, and that is going to be carrying out on a conversation with a similar program on the destination machine. So what we will be doing, we are going to be passing on some of the message headers and control messages. So based upon that, it is going to be carrying out the conversation. Now when we are going to be talking about the transport layer, so it also identifies the errors, which is going to be like damaged packets, because whenever we are going to be sending your message, some of them may get damaged, some of them may get lost, and some of the times we may get duplicate packets. So all of those things it is going to be ensuring, and at the same time it is also going to be providing you a various techniques which are going to be helping you for all those errors which we will be facing there. The protocols of the network layer are actually going to be implemented in the end system, but we are not going to be doing it at your network routers. And at the same time, we will see that we have various services, and those services are actually provided by the protocols of the transport layer, and those ones are actually going to be something like multiplexing, demultiplexing, reliable data transfer, and the guarantee of the bandwidth. So that is what is actually desirable. And when we are going to be talking about this particular layer, so we can say this layer actually provides the it can provide the transparent transfer of data between your end users, and it is also going to be providing the reliable transfer of the data to the upper layers. Now I will be drawing out how does it actually works. So let us say this is your transport layer. All right, now in this particular one, we are going to be having some of the data, and from where it is actually going to be coming from your session layer. And after this, where it is actually going to be going to your network layer. All right, now in this particular one, what we will be doing, so whatever messages it is going to be coming, so that one is going to be just sending the data, and this one is going to be adding some header to that data. So that is how all your packets are going to be there, header and some of your data. All right. And then what it will do, it is going to be breaking it down into some segments, and then it is going to get sent to your network layer. So this is how the flow is going to be there. So from session layer it will be coming, and after coming here it is going to go to your network layer. All right. So that is how your data is going to be there when you are going to be sending it. And let us say you are receiving something from your network layer. So how it will go? So here it is actually going to be taking it entirely. So that is how it works when you are sending a data from your session layer to your network layer. When we will be sending it from network layer to session layer, I'll show you how it is actually going to be there. So let us say here we have your network layer. Here we have your transport layer. And here we will be having your session layer. So here we will be having your data with your header and whatever data you have. What it will do when you are going to be sending it from your network layer, so it is going to actually have both of your things. But when we have to talk about the session layer, it does not even want your header. So what is going to happen, from here only your data will go. From here only your data will go. It is not going to be sending it entirely, only the data it is going to be sending from one point to the another one. Now if we are going to be discussing about what all the functions are going to be there for the transport layer, so let's look into it. Functions of transport layer. All right. So in this particular one, you know what is the first thing which it offers, that is service point addressing. Service point addressing. So what does it actually means? So your transport layer is actually going to be having some of the header, and that header is going to be having the information like your service point address, which is going to be a port address as well. And this layer is going to get the message to the current process on the computer, like your network layer. And how it is actually going to be helpful, because that is actually going to ensure that each packet is actually going to the current computer, it is not going to the wrong one. So that is how your service point addressing is going to be helpful in that. The next one which we have is segmentation and reassembling. All right. So in this particular one, what is actually going to be happening? So you are going to be having a bigger message. What it will do, it is going to be breaking down into some of the segments, and those segments are going to be transmittable, which you can transmit from one point to the another one. And each of those segments are going to be having some of the information like a sequence number, and how that sequence number is going to be helpful. That one is going to be actually helping you out in reassembling those messages once it gets delivered. So what is actually going to happen, the message is getting reassembled correctly upon the arrival to the destination, and what it will do, it is going to be replacing the packets which actually got lost at the time of transmitting it from source to your destination. The next function which we have for our transport layer is going to be your connection control. Connection control. So in this particular one, what and all things we will be having, so this one is going to actually have two types of connection controls. The first one is going to be connectionless transport layer. So connectionless transport layer, and the another one is actually going to be connection oriented. So we are going to be dealing with both of the things. So the another one is connection oriented transport layer. Now how it is actually going to be different, so you know, when we are going to be talking about the connectionless transport layer, so in that one we are going to be having a segment, and that segment is going to be considered as the independent packet, and that one is going to get delivered to your transport layer at your destination machine. Whereas when we are going to be talking about your connection oriented transport layer, so in that one, before we deliver all those packets, we will have to ensure that we are making a connection with the transport layer at the destination machine, and that is actually going to be really important when we are going to be considering all of these things. The next one which we have is going to be your flow control. All right. So when we are going to be talking about your flow control, so what is a flow control? So in this particular one, your flow is actually going to be performing from your end to end rather than through your single link. So how it is actually going to be maintained from end to end. And the next one which we have is going to be your error control. So when we are going to be talking about your error control, what it is actually going to be doing, so that error control is going to be performing end to end in this layer, and it is also going to be ensuring that whatever your complete message is there, that is getting arrived at the receiving transport layer properly without any error. The error correction is done using retransmission. So if it is having some of the error, you are going to be performing some retransmission there. Now I will actually show you how the process to process delivery works. So your process to process delivery. All right. So in this particular one, what we will be having, we are going to be having two systems. One is going to be your source, another one is going to be your destination. So let us say here we have your source. Here we are having your destination. And now at both of the ends, we are going to be having several processes. So let us say these are your processes. All right. Here also we will be having some of your processes. All right. Now what is going to happen? We are going to be ensuring that when we are going to be talking about these two, so at that time we will be ensuring that we are performing hop to hop delivery. So host to host delivery. And here what we will be actually ensuring that when these processes are actually getting transmitted from one point to the another one, so this one we will ensure that we are actually performing at your transport layer only. All right, so that is what the functionality which we will be seeing whenever we will be performing process to process delivery. Now the next one which we have here is UDP protocol. All right, so when we have to talk about the UDP protocol, so what is actually UDP? So the full form of UDP is user datagram protocol. So your UDP is user datagram protocol. All right, so in this particular one, what actually happens? So in this one, we can say that whenever we're going to be talking about your different protocols which your transport layer is going to be having, UDP is going to be one among them, and it is actually going to be the simplest transport layer protocol. So we can say simplest transport layer protocol. All right, also at the same time, what we can say, it is actually going to be providing a connectionless and unreliable transport protocol. So we can say connectionless and unreliable protocol. All right, also in this one, what is actually going to be happening? So this one, why it was actually designed? So this was designed so that you can send a data on your internet from one point to the another one. And when we are going to be using a UDP, so what is going to happen? It is not going to be adding anything to the services of your internet protocol, except what UDP is going to do, it is going to be providing the process to process communication rather than host to host communication. So previously you have seen what we were doing. So we were actually ensuring your host to host delivery, but what your UDP does, it is actually going to be happening in your process to process communication. And when we are going to be talking about the UDP, so it actually performs a very limited amount of error checking. And in this particular one, when we are going to be using this protocol, so it is actually going to be seeing that we are using very minimum number of overheads. So let us say we have a process which wants to send a small message with no concern to the reliability. Then what we can do, we can use your UDP. And this protocol is simply going to be taking the datagram for your network layer, and what it will do, it is going to be attaching its own header, and after that it is going to be sending it back to the user. So that is how your UDP is going to be working. Let me show you how does the diagram for this one is going to be there. So let us say this is how we have our packet. So in that, let us say this is your header and this is your data. Now I told you the header is actually going to be of your 8 bytes. Now inside that we are going to be having two things. So this header is actually going to be divided into two parts. So the first one is actually going to having the source port number, and another one is going to be having destination port number. So source port number and here destination port number. SPN is source port number and DPN is destination port number. Alright, and both of these are actually going to be of 16 bits. So here we are going to be considering the total length of 16 bits, and in your destination port number we are going to be considering the checksum of 16 bits. So that is how it is going to be there. So now you can consider what and all we are having. So we are having a fixed size of header which is going to be of 8 bytes, and with the help of this diagram you must have understood how this header is going to be get composed. So this one is going to be having your source port number as well as the destination port number. Along with that, like the source port number is going to be having the total length information, and your destination port number is going to be having the checksum information. Now we are going to be discussing about what and all operations of UDP is going to be there. So operations of UDP. So what and all operations are going to be there? So the first one which we will have is connectionless services. So whenever we are going to be using UDP, so we will also be seeing that we are actually performing it on a connectionless service. So connectionless service. Apart from that, what and all things does it actually offer? So the flow control and the error control. So we can say flow control and error control. Apart from that, what does it actually offer? It offers encapsulation and decapsulation. So what does encapsulation means? Wrapping up the data in one unit. At the same time, decapsulation means breaking it down into smaller ones. So encapsulation and decapsulation, de-encapsulation or decapsulation. Alright, so these are actually going to be the various operations which ODP actually offers. Now we are going to be discussing about your TCP. So what your TCP is going to be there? So TCP actually stands for Transmission Control Protocol. Transmission Control Protocol. Alright. Now when we are going to be discussing about what the TCP is actually going to be there. So this one is actually one of your transport layer protocol. And when we are going to be talking about the TCP, so what it is actually there, this is a connection oriented protocol. So when we were talking about the UDP, that was connectionless. But when we talk about TCP, this is connection oriented protocol. Alright, apart from that, when we are going to be talking about the TCP, so what we can say, this is a reliable protocol which we use for the transport layer, and whenever we are going to be delivering a stream of the byte, so in this one it is going to be ensuring a end-to-end in a particular order. So here order is also going to be coming into the picture. So what we can say for the TCP, that it is the responsibility of the transport layer to provide end-to-end communication, and how it is actually going to be implemented with the help of your TCP, that is Transmission Control Protocol. Now what and all are the features of your TCP? So let's discuss features of TCP, that is a transmission control protocol. So the first one is going to be your numbering system. The second one is going to be your flow control, error control, congestion control, and full duplex. So the first one is your numbering system. Then you have flow control, you have your error control, congestion control, error control, congestion control, and at the same time we will have one more thing, that is going to be a full duplex. So these all are going to be the various features which your TCP is actually going to be offering. Now if I'll have to show you how does it actually work, so like how the format is going to be there for the same, so let me try and show it to you here. So in this particular one we are going to be having your data. Now for the data only we are going to be having a defined format for the same. Okay, so let us say this is how you have your header and your data. Now for this header only I'm going to be drawing it out. Okay, so this is how it is going to be there. So the left part is going to be having your source port address. So here you will have source port address, and here you are going to be having your destination port address. So destination port address. Now your source port address is actually going to be of your 16 bits. So this is of 16 bits. Even your destination address is going to be of your 16 bits. After this, what is the next thing which we will be having? That is your sequence number, and that sequence number is going to be of 32 bits. So here you will have sequence bits, and that is going to sequence number, and that is going to be of 32 bits. All right, and after this we are going to be having one more thing, and that is going to be your acknowledgement number, and that acknowledgement number is also going to be of 32 bits. So acknowledgement number, which is going to be of 32 bits again. So you can see how this header is actually going to be combined. After that we have h length, that is your length, and it is going to be of 4 bits. So here we will have h length, which is of 4 bits. Apart from that, we are going to be having some of your reserved bits. So here you will have reserved bits, reserved, which is actually going to be of 6 bits. And then we are going to be having some of the other bits, which is actually going to be like your URG. You are going to be having your ACK, PSH. So all these are actually going to be storing the information. Your PSH. Along with that, you are also going to be having SYN and FIN. So synchronization number, FIN. And after that, we will be having something here. The last one is going to be for your window size, and that window size is going to be of your 16 bits. So all that information we will be having. Now in the next one, what and all things we will be having? So we will be having the information for your checksum, which is going to be of 16 bits. And along with that, we will be having some of your urgent pointer, which is again going to be of 16 bits. All right, and after that, we are going to be having some operations and padding. So through this, you can consider it is actually going to get composed, and all these informations we are going to be having in the header of your TCP. So options and padding. So that is how your header is actually going to be there for your TCP. All right, so that is how you can consider it is going to be having all this information within it. So when we are going to be talking about your TCP connection, so you know what and all things we will have to see here, that it is a connection oriented protocol. In this one, it is going to be establishing a virtual path that is going to be at your source and your destination, and whatever the segments we are going to be there in your message which we are sending it. So in that one, we will be ensuring that we are actually enabling a connection establishment phase. We are also having a data transfer phase, and we are also having the connection termination. So it is actually going to be going through all these 3 phases. Let me just write it down here. So what we can say in the TCP, your transmission is actually going to be having 3 phases. So in TCP, transmission will be happening in 3 phases. So what and all those 3 phases are going to be there? So first one is going to be your connection establishment phase, connection establishment phase. Then the next one which you will be having is going to be your data transfer phase. After that, you are going to be having some as connection termination. All right, so these are going to be the 3 phases which your TCP is actually going to be having. Now, if you are going to be talking about what and all differences are going to be there between your TCP and UDP. So when we talk about the TCP, so it is a connection oriented protocol. But when we talk about UDP, it is a connectionless protocol. Then if we are going to be seeing about TCP, so in this particular one, the header size is going to be of 20 bytes, whereas the UDP header size is of 8 bytes. In the TCP, the protocol rearranges the data packets in the specific order, whereas in the UDP, there is no concept of ordering because all the packets are going to be independent of each other. The TCP actually is a reliable protocol because it is going to be ensuring the delivery of each packet, whereas when we are going to be talking about the UDP, so in this particular one, we are not ensuring the data packets, and that is going to be unreliable one. So when we are going to be discussing about TCP, we can say that it is a connection oriented protocol, which means that we actually there will actually be a need for the establishment of the connection between before transmitting the data over the network. But when we are going to be talking about the UDP, so it is a connectionless protocol, so there is going to be no need of establishment of the connection, and also there is going to be no need where the system is actually going to be ready and it is going to be receiving the data. And when we are going to be talking about TCP, so just now I have shown you the header for the same, so you know what and all things which we had there. So we were actually having some of the handshake protocols, and what and all those handshake protocols were there. All these ones are actually your handshake protocols. All right, but if we are going to be talking about UDP, so there is no concept of handshaking. So that is how these two are going to be different from each other. Now, what and all other differences which we are going to be having here. So when we are going to be using the TCP, so it is going to be working on a slow speed, but if we are going to be looking into the UDP, so that is going to be faster. In this one, like in the TCP one, so whenever we are going to be talking about the acknowledgement segment, so you can see here we have something like acknowledgement numbers, and that one is actually going to be responsible for acknowledgement segments. Whereas when we are going to be talking about UDP, so there is going to be no acknowledgement segments. When we will be discussing about TCP, so in that particular one, it is going to be performing some error checking, and it is also going to be offering the recovery from all of the errors. But when we talk about the UDP, in that we do not have any concept of error checking, but UDP actually discards whatever the packets are going to be having the error. In your TCP, whatever the packages you are going to be sharing, so that one is going to be making a way from the internet from one computer to the another. Whereas when we are going to be talking about TCP, so in that particular one, whenever we are going to be sending the messages, it is going to be having a lot of packets. So one program can actually send a lot of packets. Now, if we talk about TCP, so in that particular one, whatever the flow control mechanism is going to be there, so that cannot send too many packets to the receiver simultaneously. Whereas when we talk about the UDP, so in that particular one, there is no flow control mechanism available. In your TCP, when we are actually going to be performing a lot of error checking, that is actually offered by your TCP, and that one is also going to be providing the error control, as well as it is going to be ensuring that data is getting received. So it is also going to be responsible for the acknowledgement. Whereas when we talk about UDP, so in that particular one, a single error checking mechanism is provided by the UDP, and it is also be used for checksum. Now, when we talk about TCP, so in that particular one, retransmission of data packets is possible when we are going to be using TCP in cases of lost data packets. But when we talk about UDP, so in that, retransmission is not possible when you are going to be using UDP. So that's all we actually had about your network layer and the transport layer. I hope you found it interesting. Now we will be meeting in our next class. Till then, happy learning. Bye-bye.